Okay, so we are going to talk about parallel lines today. And we're going to actually start with a little investigation, and then our ultimate goal is to be able to write equations of parallel lines. So here's some parallel lines. Hopefully you know what parallel lines are. They are lines that never touch, and they never intersect. And so I'm going to actually give you some directions, and then I'm going to ask you to pause the video and complete this investigation. So as you can see in the investigation, each graph contains pairs of lines. Calculate the slope of each line. So for each line, I want you to find the slope. I want you to pick 2 points. For example, like on this red line here, I want you to pick 2 points there, and I want you to calculate the slope between those 2 points. Count, rise over, run. And then there's a couple questions over here that I want you to be able to answer as well. So I'm going to have you pause this video now. You're going to complete this whole investigation. So it might take you like 10 minutes or so. That's okay. And then when you unpause, I'm going to quickly go through and review everything with you. So pause the video now. Go ahead. And then we'll go over it. Okay, so hopefully you went through this whole thing and counted some slopes and answered some of these questions, and hopefully you, noticed some things. So I'm going to go through and quickly go through, review the slopes with all of these graphs with you. So letter A, in graph A, when I count rise over run, the red slope is 2 over 1. And if I pick 2 points on the blue line, it's also positive 2 over 1. The red line over here in letter B is negative 1/3 because I have to go down 1 and then 1, 2, 3 to the right. And then if I pick 2 points here, this slope is also negative 1/3. And then hopefully you're noticing this pattern. In letter C, I'm going to just pick this point and this point. So this slope is positive 1, 2, 3, 4 over 1, or in other words, just 4. And the same thing for the slope in the blue line. Letter D, this slope is positive 1/3, but this slope here is positive 1/2. And if you look really carefully, these 2 lines in letter D are not really parallel. If I were to continue these are going to kind of intersect at some point. Not for a while, but they do intersect. And so, So the questions, what pattern do you notice about the slopes? So A, B, and C are parallel lines, and their slopes are the same. And if you think about it, parallel lines never touch. They can never intersect, so they always have the same steepness. Well, the slope is the steepness of a line, right? So it should make sense that they have the same slope. Do all the slopes fit the pattern? No. Letter D are not parallel, and therefore their slopes are different. Slopes are not the same. Okay, so fill in the blanks. Parallel lines have the same slopes, but they actually have different y-intercepts. So let me go back for a second. Look at like letter A. Here's the y-intercept of the red line. Here's the y-intercept of the B line. Y-intercept, 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 y-intercept. If they had the same slope and the same y-intercepts, they would actually be the same line, right? So parallel lines are going to have the same slopes, but they're going to have different y-intercepts. So let's pause for a second. Parallel lines, we know, are lines that never touch. and they have the same slopes and different y-intercepts. So here's an example. These lines, we can see that they're parallel. The slopes are both 2, but this y-intercept is the 0, 1, and this y-intercept is the 0, 3. Different y-intercepts. Because again, if they had the same y-intercepts, they'd be the same line. And then they wouldn't be parallel because they'd be overlapping. All right, so let's use that information to write equations. So write the slope-intercept form equation of a line parallel to y equals negative 5x plus 4 and going through that point negative 1, 4. So you can do this one of two ways. And actually, I'm going to take you through 2 examples, and I'm going to use one method for the first example and a different method for the second example, and then you're going to pick which one you like better. So when I write an equation, I can either just plug directly into y equals mx plus b slope-intercept form, or I can use point slope form and then solve for y. So I'm going to use this one, and I'm going to plug directly into y equals mx plus b. So I need the equation of a line parallel to this. So parallel lines have the same slope and different y-intercepts. So what do I know? I know that the slope is going to be negative 4, but I know the y-intercept is not going to be 4. I'm sorry, the slope is negative 5. I think I said negative 4. So my slope I know is going to be negative 5, and my y-intercept cannot be 4. And I want it to go through this point, negative 1, 4. Well, now what do I have? I have a slope and I have a point. My point gives me an x and a y. So this is old news. Now I'm just going to write the equation of the line. So I'm going to plug into y equals mx plus b. My y value in the point is 4 equals, my m is negative 5. My x from the point was negative 1, right? And then plus b is what I'm trying to find. I'm trying to find that new y-intercept. So again, here's where I got the y, that 4. My m I really got from the original equation because I know it's going to be parallel to that. And then the x comes from the point, and I'm trying to solve for b. Now I have my equation. I'm just going to solve this for b. So I have to multiply negative 5 times negative 1, and then I'm solving for b. I'm going to subtract 5 from both sides, and I get negative 1 equals b. So my equation is negative 5x minus 1. And I can see it has the same slope, that negative 5, but now I have a new y-intercept. And if I were to graph this line, it is going to go through that point, negative 1, 4. Okay, let's try another example. But this time, I am going to use point slope form. So y minus y1 equals mx minus x1. And again, it doesn't matter which form you use. I'm just showing you one of each form, and then you pick which one you like. So what's the slope-intercept form equation of a line parallel to this, y equals 4x plus 3. So I know my new slope has to be 4 because it has to be the same, but what do I know? My y-intercept is not going to be 3, and it's going to go through this point. Well, this is like my x and y that I'm going to use to plug into point slope form. So point slope form, y minus my y1 was that 9 equals my m is 4. Remember, I got that from here. And then in parentheses, x minus x1, which is 5. Okay, so now that's my equation in point slope form. It's asking for it in slope-intercept form, so that's y equals mx plus b. So I just got to take a minute, and I got to solve this equation. I'm going to distribute the 4, and I'm solving for y. So this will be 4x minus 20. And then to solve for y, I'm going to add 9 to both sides, find the like term, and I have y is equal to 4x, and then use your calculator, negative 20 plus 9, negative 11. So there's my equation. And you can kind of see also, I'm going to very quickly, if I just were to plug in directly to y equals mx plus b, my y would have been 9, my m would have been 4, my x would have been 5. And if I go through and solve this, and I know I'm going pretty quick, but I would get the same thing for b. So my equation would still be y equals 4x minus 11. It doesn't matter which method you use. Okay, so you're going to pick one of those methods. You're going to try some of these problems. Pause the video, try these, and then we'll go over them. Okay, so number one, write the equation of a line parallel to this. So I know parallel lines have the same slope. So my slope has to be negative 1/4. And it's going to go through this point, xy, right? So I'm just going to use slope-intercept form. So 4 equals negative 1/4 times 12 plus b. Use your calculator. Negative 1/4 times 12 is actually negative 3. And then I'm solving for b, so I'm going to add 3 to both sides, so 7 is equal to b. Well, my equation now, I need to plug in, I need the slope, and I need the b value. So that's my equation. Y equals negative 1/4 x plus 7. Number 2, we need the equation line parallel to this. Again, parallel lines have the same slope, different intercept, and this is the x and this is the y. So I'm going to plug in y equals mx plus b. So my y value is negative 3 equals my m, negative 6. My x is negative 2 plus b. So negative 6 times negative 2 is positive 12. And then I'm solving for b. So I'm going to subtract 12 from both sides. Use your calculator. Negative 3 minus 12 is negative 15. So now I have my b value. And I know my slope is the same from the original. So negative 6x minus 15. That's my line that's parallel and passes through that point. Okay, last but not least. So find the equation of a line parallel to that goes through that point. Here's a big hint. You have to do something differently with this problem to find the slope. So what do we know about parallel lines? They have the same slopes. But can I get the slope from that equation? Not as is. So I'm going to have to take this equation. I'm just rewriting it real fast. But I'm going to have to take this equation and in order to find the slope, I have to solve for y. It has to be in y equals mx plus b form. So to solve for y, I'm going to subtract 2x from both sides. And I have 3y equals negative 2x plus 6 because the 6 and the 2x are not like terms. I can't combine them. And then to get y by itself, I have to divide by 3. I'm dividing everything by 3. And I get y is equal to negative 2/3 x plus 6 divided by 3 is 2. Well, now don't forget, all I have done is solved that original equation for y. And then I'm going to pick out the slope. So my slope is going to be negative 2/3, and my y-intercept is not going to be 2, right? It's going to be to something different. So if I look at the point that they give me, I'm going to hopefully notice that they gave me 0, a number. And when you give me an x value of 0, that y value is my y-intercept. So guess what? I don't even have to do any more work. It's y equals negative 2/3 x plus 5. And if you don't trust me, we could plug in y equals mx plus b. My y value is 5. My m is negative 2/3. My x from the point is 0 plus b, right? So I use the 5 for y and the x for 0. Now, negative 2/3 times 0 is 0. Solve for b. Subtract 0, so 5 equals b. But again, I don't really have to do that plugging in work because if I notice, 0, a number, that's my b, it can just go right into that equation. All right, that's it for today. Thank you so much for watching.